I have revised my videos and have decided to do new videos with the intention to fill the gaps I have not explained well previously. Let's do a fresh start with even fresher graphics. Let's go through my world again with a hint of Lego. Yes, Lego. I'll make a Lego apple first, and I'll break it. Boom! Here, look at this piece. Let's imagine that this is an atom, which is the basic unit of stuff, aka matter. This piece has two parts, the stud and the brick. The stud is the electron, which spins around the nucleus. This spin's scientific name is called an orbit. The brick represents the nucleus, which we talked about. Here is a picture of the Bohr model. The nucleus is made of protons and neutrons. The proton gives off a charge. This charge is positive, like on a magnet. The other side of the magnet is negative, and so is the charge of the electron. Also, like a magnet, like charges repel and opposite charges attract, so electrons are attracted to protons. However, there are also shells of electrons around the atom. Remember, like forces repel each other, so if you pack the electrons in too close, boom! Right now, I also have to give special thanks to channels Starburst Studios and Zoe Star Dragons for promotion on their main page. Please give feedback on our videos in the comments to help us improve this channel. For our next focus, let's turn to the periodic table. There are 120 squares on the periodic table. On every square, excluding the lanthanoids and actinoids, there are 1 or 2 letters. However, we need to look at the decimal number. The number is named the atom's molar mass. For example, the square labeled Fe, which belongs to iron, has a molar mass of 55.845, which means a mole of iron weighs 55.845 grams. Before we define a mole, let us introduce you to Avogadro's number. Avogadro's number is approximately equal to 6.022 times 10 to the 23rd power. It is very important in chemistry, and I strongly suggest that you keep its value in mind. Just as there are 1,000 grams to a kilogram, there are also 602,200 million trillion atoms to a mole. So that means that one iron atom weighs 0.0000927 grams. You see, this weight is very, very small. That's why we normally use Avogadro's number to convert atoms to moles and not the other way around. When there is a large number like Avogadro's number and we have to write it down, you can use scientific notation. You write it using a decimal below 10 times a power of 10. For example, when the number is 7,684,672,709, we can round it to 2 or 3 decimal places. That's 7.68. And count the number of digits in the original number. Take away 1 and put that number on the right shoulder of 10. That's 10 to the 9. So the number we wound up with is 7.68 times 10 to the 9th power. There's a different example on the screen. Here's a question I'm going to pull about on YouTube. If a mass of pure copper weighs 190.638 grams, how many atoms of copper are there? Answer in scientific notation. Next, we'll talk about bonds. Now, there are no relationships, or I should say I deny that there are, between any atoms. However, there are other ways that atoms willingly stay together. So electrons are not packed in a sphere, but instead it will come in shells of different shapes. Valence electrons are the electrons on the outermost shell of atoms. Valence electrons play a big role in bonding because every atom wants 8 or none. 8 valence electrons motivate the atoms to bond. You can find the amount of valence electrons using this method. 1 and 2 valence electrons in columns 1 and 2, and 3 to 8 valence electrons in columns 13 to 18. Not 3 to 8, 13 to 18. The first of the 3 bonds is the ionic bond. Ionic bonds form when an atom wants to give away electrons, 1, 2, or 3 valence electrons, and another atom wants to get electrons, 5, 6, or 7 valence electrons. The atoms would exchange electrons. However, the atom that gets electrons now has more electrons than protons, and vice versa. So the receiving atom has a negative charge, and vice versa as well. This means that the 2 atoms are attracted. Secondly, covalent bonds are formed when neither atom has enough electrons to make 8, scientific name octet. This bond happens between columns 14 and 17 of the periodic table. The atoms come to agreement and share their electrons. This means that 2 oxygen atoms, 12 valence electrons, can share 2 electrons each and both get a full octet. The third type of bond is effective to metals only, columns 8 to 12. The metallic atoms pool their electrons and that's it. Simple, effective, and everyone gets electrons. I am proud to say that I'm a member of the metal community, but up thorium, let's not talk about that. Let's do examples. For instance, potassium bromide, or KBr. Which type of bond does it use? Let's see. Potassium lives in column 1 and bromine lives in column 17. Those 2 columns use the ionic bond. Alright, so we've took the first step towards making the videos more precise. Congrats to me and applause to you, viewer.